Hello, my name is Noriko Yasui.
Hello, my name is Eunwoo Choi.
We're going to talk about Wolfram Alpha localization. Hello, my name is Noriko Yasui. She is Eunwoo Choi. We're going to talk about Wolfram Alpha localization. So we will proceed today's talk along this outline. We start from introduction to Wolfram Alpha. We discuss Wolfram Alpha localization project. We give overview, challenges, and current status. And she's going to talk about localized Wolfram Alpha features. And after that, I will talk about Japanese Wolfram Alpha. I do some demo using Japanese Wolfram Alpha live site. And then I'll summarize briefly at the end. So introduction to Wolfram Alpha. What is Wolfram Alpha? I hope everybody here knows Wolfram Alpha. What is Wolfram Alpha already? But just in case, what is Wolfram Alpha? So it's a unique system for computing answers and providing knowledge. We call it computational knowledge engine. So the goal of Wolfram Alpha is to make the world's knowledge computable. We released Wolfram Alpha May 2009. It's like 9.5 years ago. And it started from public website. And then the public website is, I think, most popular product of Wolfram Alpha now. But it's not just a it's not just a website anymore. It's way more than that. There are so many Wolfram Alpha, so many products that powered by Wolfram Alpha technology. Let's make it bigger. So there's a Wolfram Alpha mobile and web apps powered by Wolfram Alpha and Wolfram Alpha Pro. It has quite strong feature, step-by-step solutions, program generators, or like Wolfram Alpha powered apps, and then there's Wolfram Alpha appliances, and there's Wolfram program generators tools, and you can even use Wolfram Alpha in Wolfram language, and there are developer products too. So, and then as a latest Wolfram Alpha product, we released Japanese Wolfram Alpha this year, June this year. So Wolfram Alpha localization project overview. So the goal of Wolfram Alpha is to make world knowledge computable. The goal of Wolfram Alpha localization project is to make computation knowledge more accessible and useful internationally. This is roughly more than 2 years project. The project team consists of translators, data curators, developers, testers that are language natives. Dozens of people are involved to different degrees. And the localized Wolfram Alpha is built on top of the regular English language Wolfram Alpha. And the first release goal, 1.0 version release goal, is to make all math-related features in Wolfram Alpha localized to Japanese, Spanish, and Chinese, and Korean, French, and Russian. For the input, localized feature can be queried in both the localized language and English. The rest feature can still be queried normally in English. For the output, features fully localized will generally show a completely localized output. Others may show up as a mixture of localization language and English. For the current status is we just released Japanese Wolfram Alpha version 1.0 June this year. And then Chinese and Spanish will be the next. And then the Korean, French, Russian will be after that. And what exactly we have been working on? We have lots of huge amount of data and linguistic patterns and code to localize, but it's not just a translation. It's way more than that. We have lots of language specific issues to resolve. For example, word variations. Some languages have inflections like plural and singulars, but the others don't. And like French, they have grammatical genders, but the other language don't have such thing. And like, in grammatical cases, some languages have nominative, accusative, genitive, dative, and like Chinese, Korean, and Japanese have honorific form, but the others don't have such thing. And then some languages have classifier, major counter words, and like English, they have indefinite articles, but the others don't. And of course, sentence structures are different, and then ordering of parts are different, and then partition of sentence are different. So, like English, French, Russian, they use space between words, but Chinese, Japanese, and Korean, they don't use space between words. So, and even math operator can have different meaning each language. For example, like tilde is used for Boolean not operator, but it is used as two when it's used in between numbers in Korean, Japanese. And the other thing is comma. Comma could be decimal point, or this is splitter, or just simply comma. So there is ambiguity between 1, 2, 3, 4, and then 1.234. She's going to talk about this later. So it's not just translate from English to other language, but we have to think about special handling and special heuristic to for the specific issue for the specific language.
Thank you, Noriko, for giving us an overview of our project. So in the next few minutes, I'm going to give you a little demonstration of different features in the localized versions. So these features are really what creates an amazing user experience for users in the other countries. So first, let's take a look at how different input language affect the output. So here, I'm showing you English version and Korean version, and I typed integrate 1/x from 1 to 2 in my native language, Korean. And Wolfram Alpha is actually giving us two kinds of output. One is mathematical output. So the equation and the plots, this stays the same across languages. However, for like language text, so the things highlighted in the reds are presented in the local language. So the button box and the pod title and the gray text, which associate with the math content, will help to guide you in your native language. So these features make output easier to comprehend. And another thing worth mentioning is that localized Wolfram Alpha understands two languages, English and language of the localized version. So when typed in either language, English or your native language, then output is given in the target language. So you can switch. It is possible because localized Wolfram Alpha is actually built on top of the English version. So you can switch the language you put in as an input, and you will get the same output in the localized language. And not only can you type the input in either language, but also you can type the same question in multiple different ways, and you will still get the same output. So in every culture, in every language, things do not always translate one-to-one. So I'm going to talk about different default unit system and localized date format, localized number format, and decimal separator as an example. So localized Wolfram Alpha uses different default unit system depending on variety of factors. This includes the language of localized version itself and the IP address of a user. So I typed in distance from Paris to Champagne as an input and in the English version and Korean version. And I set my location as if I'm in Champagne and Seoul. So because USA is one of the 3 countries that have not adopted a metric system, as you can see on the output for the English version in Champagne, your output is given in imperial system. But as you can see in the rest of the output is given in SI system. So that user does not have to convert the units, but they can choose to convert it manually in the preference tab. Another important aspect of translation is date format. So each country uses a different date format. In China, in Japan, and Korea use year, month, day format, but in Spain, France, Russia uses day, month, year format. And also, each country uses either 12-hour time format or 24-hour time format. And in China and Korea, we use 12-hour format, and so it indicates evening and morning. However, for the rest of the country, Japan, Spain, France, and Russia uses 24-hour format. So this is supported because local users have a best experience when they feel that the product has been developed just for them. So and I'm gonna talk about the number format for the next. So before we get into the number format, which number will be more familiar to English speaker? It will be the left one, right? The 45.86 million. But for Chinese, Japanese, Korean speaker, actually the 4,586 10,000 is more easier to read. And it is because these 3 languages have a different number system. So let's take a look at this grid. So each language have a different number format that they use. For example, in English, there's a name for 10 to the 6, which is million, and 10 to the 9, which is billion. However, for Korean, Japanese, Chinese language, there's no name for those two numbers. But instead, there's a name for 10,000 and 100 million. And another reason why using correct name is important is because there may be a same name representing 2 different numbers. So for instance, if you look at the English, billion, that represents 10 to the 6. But in Spanish and French version, Spanish and French language, or any other European language actually use billion to represent 10 to the 12. So for this reason, in the English and Korean, Russian, or other localized version, output is given in the number format they use in the locale. So these 3 numbers are actually the same number, but with a different representation. And if you take a look at the English and the Russian version, they use 45.86. So English version uses dot as a decimal separator, and in Russian version, they use a comma as a decimal separator. So that's what I'm going to talk about the next slides. So dot is used as a decimal separator in China, in Japan, and Korea. But a comma is used as a decimal separator in Spain, Russia, and France. And we also support the input for decimal separator. So if you take a look at this, so I typed input integrate 1 over x from 1.2 to 1.4. So in the output, in the mathematical expression we get, you can see the comma is used instead of dot as a decimal separator. But actually, it's not on this slide, but if you actually type in integrate 1 over x from 1 comma 2 to 1 comma 4, then Wolfram Alpha correctly interpret 1 comma 2 as a number instead of a list of a number. So in Spanish and French version, comma can be used as a decimal separator in the Wolfram Alpha language version. And the last thing I want to talk about is a new content that's available only in Korean and Japanese language. So we know in each country, math curriculum, the order which students learn the concepts are slightly different. And in Korea and Japan, education system is centered around the college entrance exam. So we actually have arranged the examples in accordance with their school curriculum system so that user can find examples easily by the topic they're taught in school. So Noriko will later talk about more about the Japanese curriculum-based layout. And I mean, there's a lot more interesting things to talk about, but I will hand it over to Noriko.
Thank you. So now about Japanese Wolfram Alpha. So Japanese Wolfram Alpha, first version was released June this year. The overall design is the same as English original Wolfram Alpha website. There's an input form window here, and then there are the links to example queries down here. The categories we localized already are written in Japanese, like here. And then these are the categories that we haven't localized yet. Those are written in English. And then, so this is the math categories. And then this is the one that Eunwoo was mentioning, that is high school math category. So click that. So in here, you can find lots of example queries that we collected from the university entrance exams or nationwide university admission test. We call National Center Test for University Admission. So we collected those tests in the past and then put them into subcategories based on high school math curriculum in Japan, like Math 1 or Math A, Math 2, Math B, Math 3. So looking through these examples, it's quite for high schooler, middle schoolers. They can easily get feel of what they should ask or how they can ask. Okay. And let's take a look at some demo. So first example is to find integration. Solve the integrate. So integrate sine x from x equals 0 to pi. Then this is live Japanese website. Not bad. Okay, anyway. So you get the answer, and then you get the visualization for the integral. And then you can even get Riemann summation, and then you get the indefinite integral. You can step-by-step solutions are also localized into Japanese. So if you click here, yeah, you can get the step-by solution in Japanese. Like step 1, calculate the definite integral, and step 2, apply the fundamental theorem of calculus. The antiderivative of sine x is minus cosine x, and then evaluate the antiderivative at the limit, and then subtract, and then get the answer too. So this is quite simple, like 3 steps, step by step. But let's take a look at next example. So hopefully it worked. So this is an example for solving equation. the answer is x equal 1 and y equal 2, and then you got a plot for that. And you can get the step-by solution for that too. Okay. So there are actually multiple ways to solve equation. Maybe like most typical way is by elimination, but there are 3 other ways, like substitution or Gaussian elimination, and then there is a least popular method, maybe Kalmar's method. Kalmar's rule, actually. Let's take a look at the step-by-step solution by Kalmar's rule. So, in step 2, express the system in matrix form, and then solve the system with Kalmar's rule, and then evaluate the determinant, and then cancel terms and simplify, and then you get an answer here. So you can even get the intermediate step-by-step, like how to get determinant for this one. If you click that, you can get the step-by-step for that. Okay. And then the last example is for finding inflection points. This is the one we supported. This is a step-by-step solution we supported recently in English, but it's localized already, but it's not online. It's accessible by this test site. But let's take a look. So there are so many steps to get the inflection point. But briefly, you have to compute first derivative, and then you have to compute the second derivative as steps 5, I guess. And then find where the second derivative is 0 by solving 6x minus 6 equals 0. And then classify, you have to classify concavity. So that for the range minus infinity to 1, it's concave down. And then for the range 1 to infinity, it's concave up. Then find where the points of inflection occur, then get the answer. So you can get those step-by-step solution in localized language. Now, okay. Okay, so the future work, of course, we have to continue to improve the support for math area. We need to minimize the rate that Wolfram Alpha cannot give any answers. And the output, we have to localize all the parts of the output. And of course, we have to expand the support area to outside of math. We have lots of useful area in Wolfram Alpha, so we have to localize that. And as a future challenge, so we have to think about to improve accessibility from mobile devices. This is very important for Japanese because Japanese spend 1 hour, 2 hours, maybe 3 hours every day on public transportation to go to school, to go to office. And then they're using mobile phone or smartphone mobile devices to kill their time. The students even study on trains, buses. So we have to think about Japanese users want to use Wolfram Alpha on mobile devices. So it's very important that they can put their query on their mobile device easily, or the output will be clear and good enough on the mobile devices. And then the next one is we have lots of nice data, city data, school data, flight data, lots of data, useful data. But those are all, not all, but mostly US centralized. So we have to localize data itself. So we have to think about how to get those data or how to curate those data. It's gonna be a big challenge for us. So summary, it's just a brief summary. We talk about localized Wolfram Alpha and Japanese Wolfram Alpha released June this year. And 5 more languages will be coming soon, hopefully. And then we will continue to improve the math area support and expand support area. Thank you.